I will try to record this. So again, okay, don't forget to actually extract step by step. So first thing first, you have to extract info. So extract info. So you can actually have what? Okay, phosphoric acid, H3PO4. That would actually be 25 centimeter cube. Okay, with of 1.25 concentration. Okay, so mole per dm cube. Okay, minus 3. Okay, now after that you actually have your volume of ammonia, so NH3. Okay, and NH3 with a volume of 45.3. Okay, point 0.3. Okay, cm cube. Okay, so again, okay, what you need to do is actually to find mole of your particular I want a concentration. So concentration is unknown. Okay, so first find mole of H3PO4. PO4. Okay, that would actually be C times by V. Okay, C times by V. Okay, so concentration is 1.25, then volume is 25. And remember that particular volume should actually be in your particular dm cube. So you have to convert the cm cube to dm cube. So you can actually put bracket, okay, 25 divided by 1000. Okay, now from there you would actually be able to find, okay, that particular concentration, sorry, mole phosphoric acid given to you is, okay, 25 divided by 1000. Okay, that would be 0.03125. Okay, mole. Okay, so that would be the mole of your particle phosphoric acid. Now next I'm actually have to find mole of ammonia. Okay, sorry. Okay, mole of ammonia. Okay, so mole of ammonia, NH3. Okay, would be, okay, using mole ratio. So using mole ratio, come on, okay. Now, in terms of this, okay, good, okay. This one, what we're gonna actually do, okay, we look at the mole ratio. So NH3 to phosphoric acid, okay. H3PO4, okay. Now that would be 3:1, okay. So now you actually have your particular mole of H3PO4, but I don't know what's the mole of NH3 now. So I'm gonna actually put X, okay? And let that actually mole of NH3 to be X, okay? And okay, mole of H3PO4, you found it, 0.03125, okay? Then, okay, you cross multiply, okay? Cross multiply, okay? Then you will actually get, okay, in terms of times by 3, answer times by 3, which is 0.09375, okay, mole. Okay, so to find concentration, okay, of NH3, use the formula mole is equal to C times by V. Okay, so again, okay, that would be mole, okay, to find volume, sorry, concentration is equal to mole over volume, M over V, and V has to be in dm cube, so remember that. So C is equal to mole 0.09375, okay, divide by, okay, which would be the volume sana, okay, that would actually given to you is 45.3, okay, over 1000. Okay, so that would actually, the answer be, okay, So answer divide by 45.3 divided by 1000. That is about 2.07, okay, equal to 2.0695. Okay, so 2.07. Okay, 2.07. Okay, any questions so far?
No.
No, that's good. Okay, now let's move on to the next one. Okay, so we'll try to actually, make it fast. Now show the calculation that 4.366, okay, gram of ammonium phosphate will be produced. Assume that the yield is 100%. So in terms of this, okay, you already know, okay, what's the mole of phosphoric acid, okay? So the mole of phosphoric acid and the mole of your particular ammonium sulfate, ammonium phosphate is actually the same. So use your particular mole just now. What's the mole? 0. berapa? So this here simply, okay, you're gonna actually use, okay, mass is equal to mole times by mr. Mole of ammonium sulfate, okay, phosphate, sorry, ammonium phosphate, times by your particular mr of ammonium phosphate. Okay, so usually this is what we can actually look at. Okay, now to find mole, of course we actually use mole ratio since it's 1-to-1 with actually your particular phosphoric acid. Now why do I use phosphoric acid? Because that was given to you. Okay, so don't use the ammonia. Okay, so you don't use the ammonia. So basically in terms of that, okay, you don't use ammonia. The 1 times 3 is actually ammonia, if I'm mistaken. Okay, so the one that actually we use is actually your particular phosphoric acid, because it was actually given by the question. So it's not gonna actually be what you call that, okay, it's gonna actually be correct most of the time unless you actually have mathematical error, okay, while computing your using your calculator. For this one, okay, we don't use the ammonia. You still can use ammonia, but the thing is that, okay, is we're afraid that you might actually calculate it wrongly, okay. So we have to ask you to use the one that given by the question. So in this case, okay, that particular mole of the phosphoric acid, okay, that was given to you is 0.03125, okay. So the mole of ammonium phosphate should be equal. The reason is because of your particular, okay, mole ratio is 1:1. Okay, so I still can actually use straight away, okay, here, okay, mass of phosphoric acid is equal to, I use the mole 0.3125, okay, times by, it was given there, mr of phosphoric ammonium phosphate is 149, so 149, okay, so the answer would actually be 0.03125, okay, 0.0. So it's 0.03125, okay, divide times by 149. So it's about 4.65, okay. Now 4.66, okay, gram, okay. Now that was actually 3 significant figure. Now here, okay, this is assumptions of 100% yield, okay, but if they ask you to calculate and the question mentioned that the percentage yield is only 70%, then you have to times, okay, 70% of the mass that you calculated. Okay, remember that this is 100% yield. Okay, so if you want a 70%, 80%, 50%, okay, if they give you actually, if they want actually the percentage yield to be 50%, then you times the mass with the percentage were given to you. So far so good?
Yes.
Okay, that's good. Now, in practice, the actual mass of ammonium phosphate produced 2.93 gram. Okay, calculate the percentage yield of ammonium phosphate. Okay, so this is actually what they got. Okay, 2.93. So percentage yield is actually the amount that you got over the theoretical mass, which is the one that you calculated, times by 100. Okay, so that would actually be the formula of that particular percentage yield. Okay, so I'm gonna actually just put it here. Okay, so percentage yield. Okay, okay, percentage yield is equal to, okay, mass you got over mass you calculated, then you have to times that by 100. Okay, so I'm gonna actually just put that, okay, and in bracket. Okay, so you know what to do with that. Okay, time 100%. Okay, so in this case, okay, what you're gonna actually, sorry, okay, what you're gonna actually do, okay, you just need to actually have 2.9, 2.93, okay, 2.93 divide by 4.66, okay, then that would actually times by 100. Okay, 100. Okay, that would actually equal to 2.93 divide by answer times by 100. But about 92.9 or 93. Okay, 92.9. Okay, percent. So is it good? Okay, so is it good? Yes. Okay. Now, and let's move on to the next one. Okay, so we're gonna actually move on. Let's clear it off. Okay, let's move on. Okay, we have 1 minute. Okay. Again, question number 3. Okay, protein, carbohydrate, and fats are natural macromolecule. The partial structure of the protein shown. So this is actually, we have amide linkage. Okay, so these are actually amide linkage. Okay, or peptide bond. Okay, name the linkage of the joint, the monomer unit. Okay, so because there's actually contain nitrogen, so this is actually an amide linkage. Okay, so now name a synthetic polymer that actually have the same linkage as actually protein. Synthetic polymers. Okay, so basically in terms of this, you have to know about what the synthetic polymers like macam PVCs. Okay, apa tu namanya, any other synthetic PVC is actually by addition. Okay, so in terms of this, you actually need to, okay, apa tu, give me the synthetic polymer with actually kamu punya amide linkage. That would be nylon. Okay, so that would be nylon itself. So if it's good, nylon actually have amide linkage. Okay, now, proteins are hydrolyzed to actually give a mixture of colorless amino acids. Okay. Now, reconnect. Then actually, we're gonna actually talk about this on the second particular sections. Okay, or second session. Then, because it's less than 1 minute. Okay. So once it stopped, just reconnect it back. Okay, and I have to convert the videos first. Okay. Okay.